Welcome to section 3 of our training program. Well, we've made it, finally. We're finally going to start talking about LED and induction lights, which are loosely defined as the things which will make us money. So, without further ado, let's jump right into it. What is an LED light? LED stands for light emitting diode. A diode is simply an electronic component that emits light when electric currents pass through it. Diodes are very, very small, often less than a centimeter wide and a few centimeters long. From a practical perspective, an LED lamp acts just like a light bulb without a filament. It has an extremely low power consumption and a tremendously long life. LEDs have come a long way in a short amount of time. In 2009, for example, the media was writing things like this. Unfortunately, LEDs just don't have the lumen output needed to completely replace incandescent and other types of bulbs. Nevertheless, technology is advancing every day, and it will not be long until the LED bulb will be the bulb of choice for most applications in the home and workplace. Today, LED lumen output blows incandescent bulbs out of the water, and while it's not necessarily the bulb of choice for most applications, for people who understand the immense benefits of LED lights, their attitude is changing. Before we get into the substance of LEDs, here are some visual aids. This slide gives you some examples of common LED lights. Again, as before, this is just a small sliver of the lights that are available on the market. So prepare to spend some time doing research on other types of LED lights and discovering new ones throughout your travels. On the screen, you see a few different variations. The PAR lights are commonly called spotlights. PAR stands for Parabolic Aluminized Reflector. And you can now forget that fact since nobody will ever ask you about it again. The number after the par stands for 1/8 inch increments. So a par 30 is a total of 30 1/8 inch increments or 3.75 inches wide. And MR16 similarly is 16 1/8 inch increments or 2 inches. After you've seen a few par 38s and MR16s, par 20s and 30s, you'll start recognizing them from their size alone. LED tubes are essentially the same shape as fluorescents, although obviously the insides look much different as LED tubes have hundreds of tiny diodes rather than light bulbs. Also, they're much heavier and more sturdy than a fluorescent bulb, which shatters easily. The A19 is the LED equivalent of your basic everyday light bulb. The A is the terminology for bulbous pear-shaped form that you associate with normal light bulbs. And the 19 again refers to 1/8 inch increments at the widest part of the bulb. The GD24 and 3U bulbs you see act just like light bulbs but are used for applications other than standard lighting fixtures. We just spec the GD24s into some parking bollards, for example. As we noted before, the technological advances in the packaging and configuration of LED bulbs are as significant as the evolution of the lighting technology itself. Being able to use LEDs in common settings and fixtures is as responsible for the popularity of LED lamps today as the actual light. On this slide, you see just a few of those variations. Hundreds more exist. Let's go over a few facts about LEDs. First, LEDs don't have a filament, so there's nothing that gets very hot. LEDs run very cool. In fact, when an LED is on, you can grab it and it won't burn your hand at all. Try that with a regular bulb. Additionally, with little heat, the diodes don't burn out the way a filament does. Over time, a filament will wear out and one day it'll just burst, and that's why a bulb simply stops working. An LED runs out differently. An LED starts to dim over time. So when we talk about the lifespan of an LED, say 50,000 hours, at 50,000 hours, the LED light will be 30% diminished, not dead. LED lifespan is considered over, however, when it loses 30% of its light emission. The diodes at the heart of LEDs work by having an electrical current run through them, and they will last as long as the transistor itself, which currently is in the neighborhood of 50,000 hours. Newer lamps are claiming lives as long as 100,000 hours, and over the next few years, we'll see if the practical application matches the manufacturer's claims. At this point, it's hard to prove or disprove those claims. Remember that a year, 365 days at 24 hours a day, is only 8,760 hours. To prove a 100,000 hour claim, we'd have to run the light continuously for 12 years. Since these types of LED lights are only a few years old, we only have theory to go on, and theories, as you know, don't always prove out. Now we're going to get into all of the myriad advantages you get with LED lights. Sorry. This will go on for a while, so get comfortable. We've already spoken about a few of the advantages, but the main one is the overwhelming efficiency of the LED light. A typical T8 fluorescent tube pulls 32 watts. The equivalent T8 or T10 LED tube will pull 15 watts and provide equivalent lumens, if not more, than the old bulb. In virtually every lighting environment, the total energy required to create the identical lumen count with LEDs is reduced by 30 to 80%. If you can cut a customer's bill from $10,000 per month to $3,000 per month, do you think he would pay you $5,000 a month in financing fees to purchase the lights? The answer is yes. But remember that LEDs are not just dollars and cents. There's a larger picture to think about. If you recall from our earlier example of incandescence that it takes 714 pounds of coal to light a 100-watt bulb for a year. What happens if you replace that 100-watt bulb with an LED bulb that pulls only 30 watts? Mathematically, you've saved about 500 pounds of coal. While the actual savings is not quite that straight line, you can see that there is enormous savings of energy and resources when incandescent lights are replaced with LEDs. Think about the green movement in general. You always hear talk of new energy and solar energy and wind energy, all in the name of using different or fewer materials to create the energy. What if you simply reduced American energy demand by 30 to 40%? Think of the difference that would create in gas prices, in the geopolitical climate in the Middle East, in the way our country and our government does business. That's what LED lights have the capability of doing, and that is disruptive, to say the least. Plus, because LED lights generate virtually no heat, all of the energy used goes directly into the light itself. When the energy is focused in this manner, the lamp can generate a large amount of lumens for each watt of energy consumed. This is in direct contrast to the incandescent bulb, which wastes a vast majority, up to 90% of the kilowatt hours utilized simply to heat up the filament. And don't forget that the heat generated by these incandescent bulbs must then be cooled down by the room's HVAC system, resulting in additional energy usage beyond the lighting. Wasted energy, therefore, begets additional wasted energy. With LEDs, however, there is no heat, virtually no heat, and virtually no additional burden on the air conditioning. LED lights can also generate a wide range of colors, from warm white to cool white to a rainbow of other colors without the use of any filter. While incandescent and fluorescents have a limited range, LEDs have a virtually endless array of different colors to complement any environment. This presents a significant aesthetic benefit as well and lets the customer pick and choose a precise light spectrum for his building. This range of lighting results in certain unintended benefits. The difference in the perception of the surrounding colors was so pronounced that it literally seemed like the walls were a new color. In the same building, new LED lights were installed at one end of a hallway, but not the other. The walls at the LED lit end appeared to be light pink, which was the actual color they were painted. At the other end of the hallway, where the incandescents still were, the walls looked mustard yellow. Needless to say, the owner of the building was ecstatic with the results of the LED retrofit. LED chips are extremely small, and thus they can be configured into almost any fixture application. As noted before, LED technology has advanced not only in terms of the light produced, but in the manner in which the lights can be used in both standard and custom fixtures. Also, LEDs light up very quickly, unlike CFLs, which require several minutes to reach full capacity. While this is not a major benefit for a small room per se, when you have an application in a large-scale environment like a parking lot or a stadium, this can be a very positive advantage. LEDs are also unaffected by the number of times they are turned on or off, also known as cycling. Frequent cycling has a substantial effect on the lifespan of a CFL or a fluorescent bulb. This is an ironic condition because thousands of building owners have installed motion sensors in an attempt to conserve energy. They believe that if the lights are off when nobody's in the room, they're saving money on energy. While this is true, they're also losing money because their lights will burn out quicker, thereby requiring more frequent replacements. This is just one of many situations where consumers mistakenly use tactics to save energy, which simply don't work. For example, some buildings unscrew a single bulb in a fixture in an attempt to lower their electricity use. What they don't know, however, is that the energy usage in a fluorescent fixture is approximately the same whether the bulbs are turned on or off. This is another anecdote you can use to persuade a building owner that their existing light systems are simply not performing as expected. LEDs have a lifespan of up to 50,000 hours, and for some newer bulbs, even longer. This does not just prevent a savings in light bulbs, but also for maintenance. For many non-residential applications, it's extremely expensive to replace lights. Many car dealerships, for example, have their lights 20 to 30 feet off the ground. And to change these lights, the company may have to rent expensive lifting equipment to get their mechanics to the bulb. Other places require furniture or other equipment to be moved in order to replace bulbs. In these situations, the company does not just save money on the LED lamps they're buying, they can also avoid the substantial maintenance costs associated with constant light bulb changes. LEDs are also very durable. As opposed to incandescent and fluorescent lights, which are brittle and shatter easily, an LED light is made up of solid state components and thus very strong. While it certainly can be broken, it can withstand quite a beating without any negative effect on its performance. Moreover, LED lights are directional in that you can focus the light at a certain angle or at a specific spot. If you have, say, a customer who has high-end furnishings or art, the LED lights can be directed at an object or oriented so they illuminate a precise area. This is extremely advantageous for museums, galleries, or retail establishments that carry high-end goods like jewelry stores. Now, in addition to LED lights, induction lighting actually has a longer lifespan than LED products, and from a cost perspective, can be much cheaper than an LED solution. Induction lamps are essentially fluorescent lights with electromagnets wrapped around a part of the tube. Induction lights are generally the preferable solution for outdoor areas like parking lots or street lights and can last up to 100,000 hours without serious degradation. Induction lights do require ballasts, either external or within the light itself. However, these ballasts are nearly 98% efficient and still support an extremely long life. The ballasts not start 100% and it takes some time for them to arrive at their full capacity. Induction lights do not burn as hot as other lamps and are extremely cost effective. Their lifespans are simply massive. 100,000 hours of effective light covers nearly 12 years of 24 hours a day, 365 days a year operation. The reduction in maintenance costs alone can be staggering over that period of time. Plus, induction lights have a very high CRI, which results in vibrant colors in every space in which the induction lights are installed. So let's summarize. Induction has extremely efficient ballasts that cut down energy use. Induction lighting contains no mercury or other toxins. Induction lights are cheap to purchase and maintain. They have a high CRI and a long life. All in all, not a bad choice. Well, that concludes our discussion about the actual lights themselves. I'd like to touch on just a few auxiliary aspects of the lighting solution that we provide, which can be particularly effective in helping you close the sale. First, while many people have heard that LED lights are somewhat unregulated and do not have the consistent quality of more established lighting systems, it's simply not true. While there are LED manufacturers who do not have quality controls or who provide a shoddy product, it's just not the case with all manufacturers and certainly not the case with Maxon or its OEM partners. There are multiple international and national agencies which provide stringent standards and rating systems which ensure that LED products perform up to their stated capabilities. Underwriter Laboratories, or UL as it's commonly known, is a well-established ratings agency which most Americans are familiar with. UL rates standard incandescent bulbs as well as thousands of other products including LED, and UL rated LED lights are available in many formats. Most OEM partners, however, are based out of China where the ETL labeling system is more common. ETL is a trademark of Intertek, which is essentially the European equivalent of UL. The mark is recognized throughout the world and is available on many products. LM79 and 80 are ratings which are more specifically directed to lighting systems and are promulgated by the Illuminating Engineers Society of North America. Although this rating is more stringent and more telling of superior quality, many people have never heard of it, so despite its quality, it may not be as persuasive as the other more well-known marks. This is our final slide in this PowerPoint presentation. It may also be the most powerful one in helping you close the deal. LED and induction lights provide tremendous cost savings and energy efficiency, and utilities and governments throughout the US and the world are desperately seeking solutions to conserve energy, and our lighting solutions do that to an extreme degree. Accordingly, there is a vast network of rebates, incentives, and grants that are available from local utilities and state agencies and the federal government that all can be paid out to consumers who utilize lighting solutions like the ones that it provides. On our website, we have a link to the Foremost Guide for Rebates, dsireusa.org, which is run by the U.S. Department of Energy. This site has enormous resources to determine what dollars are available to offset the high cost of LED lighting, as well as contact information and referrals to specific agencies that might be helpful. If you want big sales, become the local expert on rebates. I'm telling you, if you provide rebates to a customer that your competitors not know about, you could have a 5 to 50% advantage over his quote. That's a difficult advantage to overcome. But you should know that many of these utilities, while they publicize rebates, have an application process that is notoriously difficult to navigate. As an example, one of our customers in Colorado was a customer of Black Hills Energy, the local utility. Black Hills has a long-standing rebate program that had accumulated $24 million in a bank account set aside specifically for rebates to customers who install highly efficient energy systems. However, despite this surplus of funds, not a single company had ever received a rebate. It's almost unbelievable. With $24 million to spend, not a single other company had ever managed to get through the bureaucratic red tape and get a check until we showed up. The moral of this story is that you must be aggressive and relentless in pursuing rebates. Utility employees are trained to make you jump through hoops to get their money because most companies won't do it. If you do, you have a huge advantage over competitors who are too unmotivated to figure out how to get the dollars necessary to make your good sale into a great one. And now I'd like to thank you for making it through these first 3 sections in this entire PowerPoint. This does conclude the PowerPoint aspect of the presentation. But no, while we provide you with a significant amount of information, this is just a starting point. There is no substitute for experience or research. The more you learn about LED and induction lighting, the better your chances of closing huge sales. Sales to individual customers has been as high as $1.1 million, and the potential for you to find similarly massive opportunities is great. However, you need to know your industry and you need to know the products. Do not rely on this brief introduction. Get on the internet, get out into the world to meet customers and see what types of lighting solutions they have. Now, remember, we have 2 more sections to this training program. In the first one, we will give you some basic instruction on how to do a light bulb count, which is the most critical aspect of the sale. Knowing what your client has and what is needed to replace those garbage bulbs is the most basic requirement of this business. And as easy as it seems to be to count a couple of light bulbs, it can actually be very complex. The next section after that, section 5, is where we go over the energy audit, which you'll be presenting to your customers. This is our secret sauce, if you will, in that it is an informative and impressive document that has swayed many large corporations to buy hundreds of thousands of dollars of products from us. While the document itself will be created internally, you still need to be familiar with its contents to effectively present to your potential clients. We'll get into more detail for both the count and the audit in the next 2 sections. And that concludes section 3 of our training program.